All right, so we're going to use the definition of derivative to find derivatives of log and exponential functions. So we're going to start with our basic exponential function, e to the x. So the definition of derivative, remember, is the limit as h goes to 0 of f of x plus h minus f of x all over h. Now, so if we substitute x plus h into our function e to the x, we end up with e to the x plus h minus our function e to the x all over h. Okay, now we got to use some rules of exponents. I'm going to factor out an e to the x. All right, so if I factor out e to the x from e to the x plus h, I'm left with e to the h. Why is that? So remember, if you're adding exponents, it really meant you were multiplying the bases. For instance, if I have x squared times x to the third, you add the exponents, it's x to the fifth. So it's kind of like going backwards and splitting it apart. E to the x plus h is e to the x times e to the h. Then if I take an e to the x out of that second term right there, e to the x, I end up with just 1. So if you FOIL that back out, it would be what I started with, e to the x plus h minus e to the x. All right, so that's all over h. Now, this is one of the special limits that we didn't really talk about. We decided to skip that and not spend a lot of time on it. But if you take your time right now and go on your calculator, you'll see that that has a limit. This part right here has a limit of 1. Well, in this part right here, doesn't have an h in it, so its limit is just e to the x. So the limit, when all is said and done, is just e to the x times 1, or e to the x. So the derivative of e to the x is the easiest derivative there is. It's just itself, e to the x. Only derivative that is its own derivative. So in general, okay, if I have to take the derivative with respect to x of e to some function, all right, it's going to be itself times the derivative inside the variable there, okay? So that's the, now let's do some examples. So find the derivative of this guy below. So if I'm taking the derivative of e to the something, it's going to be itself. But because of chain rule, we have to go inside and do the derivative inside. So the derivative of this inside part is 2. So if I rewrite that, it should be 2e to the 2x minus 1. And I have to admit, I often cheat and put it in front so that I don't have to rewrite it at the end. All right, now, this says find the relative extrema. We're just going to find the derivative because we haven't talked about relative extrema yet, and we will get to that. All right, so on this one, we're going to find the derivative. It's a product. It's a product of x and e to the x. So I'm going to actually use the product rule. So derivative of the first one is 1 times the second part is just e to the x plus. Now I'm going to leave the first part alone and take the derivative of the second part, but that's just e to the x. Woohoo. Now, I think that writing it as e to the x plus x times e to the x is absolutely acceptable. I am going to factor it just because I can. All right, and so I'm going to factor out that e to the x. I think rewriting it just with a coefficient is also fine. Factored form is simplified form, and so is expanded form. So now we're going to use what we know about the derivative of e to the x to find the derivative of natural log. And we're going to do that by changing this to e to the y equals x, because if I take this and exponentiate both sides, so I'm e'ing both sides, if you can say that, it's exponentiate. These cancel right here, so that's how I got that version, or I wrote it in exponential form. You can think of it either way. All right, so now if I take the derivative, okay, I'm going to take the derivative, so e to the y, because e is its own derivative, times the derivative inside of that, up there in that y, I have to take the derivative, dy dx, because the derivative of y is dy dx, equals 1, because the derivative of x is just 1. All right, so now I have to find the derivative dy dx. That's what I'm really looking for. So I need to solve for dy dx equals 1 over e to the y. But wait a minute, e to the y is just x. So we're going to go back and substitute that in. The derivative of y, or the derivative of natural log of x, is just 1 over x. Yay. All right, so the derivative of natural log of x is just 1 over x in general. All right, so if you have some crazy thing inside the natural log, all right, the derivative of natural log of u is equal to 1 over u du dx. All right, so let's take some of the derivatives of natural log functions. So this first one, we're going to have to use the chain rule. So the derivative of g, remember the derivative of natural log is 1 over whatever inside, so 1 over 2x, times, now the derivative inside of the natural log function is just 2. So if I simplify that, it'd be 2 over 2x, or just 1 over x when you cancel those 2's out. All right, so how about this guy? H prime of x equals, now this one has a product in it, so we're going to actually have to use a product rule. Derivative of the first is just 1 times, leave the second one alone, plus leave the first alone, and then take the derivative of the second one. And since the inside is just x, I guess you can write times 1, because the derivative of the inside part is 1. But then you'll have the natural log of x plus 1, and that's your derivative. All right, down here, this f of x, the derivative, will be, you have to use chain rule. The outermost thing is the 3, so bring the 3 down and raise it to the second power. And then take the derivative inside. Well, the derivative of natural log of x is just 1 over x. So, and derivative inside of there is just 1, so I'm not going to write it. So we have 3 natural log of x squared all over x, and that's my derivative. All right, on this one, I'm going to do it this way. The derivative is 1 over x squared plus 1. Derivative inside the natural log is just 2x, so my derivative is 2x over x squared plus 1, and nothing cancels, so I'm going to leave it that way. All right, so we're going to do a little bit of complicated ones using the natural log derivatives. So we're going to do this first one right up here. We're going to do 2 different ways. We're going to do it by the straight chain rule and using log properties first. So you have to remember a few log properties, and we'll go over those in a second. But if I just straight up do chain rule, I get y prime, or dy dx, equals 1 over the square root of x plus 1. And then I have to take the derivative of this guy in here. So we have to remember that that is really x plus 1 to the half power, okay? So I'm making a little side note here. So if I take the derivative, I bring the half down. And then I have x plus 1 to the negative a half power. And then derivative, oopsie, I missed my 1. The derivative inside of that is just 1. So simplifying that, I have 1 over square root of x plus 1. Now, I like to think of tops and bottoms, so this is 1 on top and 2 on bottom. So I'm going to put the 2 on the bottom, okay? I don't really need to write another 1 on top. Then this guy right here is an x plus 1 to the negative a half, so it means a square root, but it's a negative, so it has to be on the bottom, right? Because negative exponents really belong on the bottom. And then times 1, so I don't really need anything. Now, these 2 simplify when you multiply square root of x plus 1 times square root of x plus 1, that's just x plus 1. So we're going to combine those together, 1 over 2, and then x plus 1. All right, so that's one way to take the derivative. But if we use log properties first, we have to remember, if you have an exponent in a log, you can bring it down in front of the log, okay? And so we're going to do that. So let's think of this guy right here as y equals 1/2 natural log of x plus 1 and take the derivative that way. So you don't have to use the chain rule. So this way I get 1/2, because you don't have to do anything with the coefficients. Take the derivative inside of there, x plus 1 times the derivative inside is 1. You notice how much easier it is to get the derivative there? So the top is 1 and the bottom is 2 x plus 1. And it's just so much easier than using the chain rule. Using log properties first makes your life easier. All right, so let's try log rules to solve problems like this. So like this first one, you have to remember that if you have log of A over B, that's really log A minus log B. And similarly, if I have log A times B, that's log A plus log B. Okay, so same with natural logs. Also, don't forget the exponent rule. So really, this y equals, I'm going to split this up into logs. So we have two things that are multiplied, the top and then the bottom that's divided. So if I could split it up to log x plus log x squared plus 1. Okay, it's squared, but I'm going to cheat and just put the square down in front because remember exponents. If it was an exponent of 2 here, I can bring it down in front, and that's what I did. Okay, now this next part is divided, so it's a subtracting log because I'm dividing by that. Log of 2x to the third minus 1. And remember, that's the half power because it's a square root. So I'm going to bring the half right down here in front. So again, that was the half power, the square root. I wrote it right down in front. It's a minus because I'm dividing it. Okay. So now, if I take the derivative now, the derivatives are so much easier than having to do this craziness of product and quotient rule. What a pain. Okay, so that's 1 over x plus, I'm going to have 2. And I wrote log because I said log, so I'm sorry. I have to fix this to be natural log. So 2 and then 1 over x squared plus 1 times the derivative inside of there, so times 2x minus, and then we have 1/2, and then the derivative of a natural log is 1 over 2x to the third minus 1, and then times the derivative inside, so times 6x squared. All right, so now I can simplify. It's still a pain, but it's not nearly the pain as it would be. 1 over x plus, let's see, we're going to have 4x over x squared plus 1, and then minus, now these will cancel down to a 3, okay, so I'm going to reduce my 6 divided by a half, or divided by 2, so times a half, to minus 3x squared over 2x to the third minus 1. And there you have it. Now, you might want to combine fractions. I'm not so sure it's worth your time. This much, at least, it makes the derivative a little easier to take. Now, how about over here? This one doesn't have a log in it. But we have to do the chain rule inside the quotient rule with a square root and then try to simplify all those things. It is a pain. What if I could make that logs so that I could do that nice trick to it? So it's okay to take the log of both sides. So I'm going to do that. I'm going to take the natural log or the log of both sides, which is totally allowed when we're doing algebra. Okay, now, if I do that, now I can use my log rules. So I'm going to have natural log of y equals, and this other side I'm going to split up. So I'm going to have natural log of x minus 2. Now it's squared. I'm going to bring that 2 down in front. So remember, exponents, I'm bringing it down in front. All right, now minus, because it's dividing, okay, so subtract natural log of the square root of x squared plus 1. Now really that square root is a half power, so I'm going to bring it down right in front. So again, that was a half power for a square root, so I'm bringing it down in front because that's a log rule. Now if I take the derivative with natural logs, it's really easy. Derivative of natural log of y is 1 over y, but don't forget, take the derivative inside. Derivative of y is dy dx times 2. 1 over x minus 2, derivative inside is 1, so I'm not going to write it down, minus 1 over 2, and then the derivative of natural log is 1 over x squared plus 1, derivative inside is 2x. Done. And so I didn't have to use the crazy product chain quotient yucky rules that I'd have to use. Still have to find the derivative, dy dx equals 2 over, I'm going to write this whole thing down. I didn't write this for a reason. I'm coming back to it. Minus, now these 2's will cancel with each other, so I have x over x squared plus 1. Now, I guess I could combine those fractions. I'm not gonna. Really, this 1 over y is in front. I'm going to multiply both sides. Okay, so instead of writing it here, I'm going to multiply both sides by y, so they cancel. All right, and then I have dy dx equals this whole thing times y now. I know what y equals. That's what I started with. So if I substitute that back in, I can go ahead and get dy dx equals 2 over x minus 2 minus, I'm trying to write plus, so let me erase, minus x over x squared plus 1, all that times y, but y is that crazy looking fraction we started with. There you go. That is the derivative. Now, could we combine fractions? Yes. Worth your time? Not so sure.